So I'm going to show you a different method for solving systems of equations. The previous one that we talked about it was substitution, but sometimes it's easier to rely on a different method. We're going to call this the addition method. And it is also a method to solve systems of equations. So the example that I'm going to take right now is going to be 4x minus 7y equals negative 16, and this comes from the PowerPoint. And the other equation is 2x plus 5y equals 9. Now, before I start in the addition method, I want you guys to understand that it is hard or complicated to do the substitution method, because the substitution method would require me one of these variables to be by itself. And all of those variables, they have a coefficient other than 1 together with them. So what this means is that when I try to solve for one of those variables, I am going to create a fraction. And then this fraction, I will have to substitute in the other equation, then I'm going to have fractions all over the place, right? So if you don't mind fractions, you can do substitution method on this as well. I will not recommend it to you. So I'm going to show you how to do addition method right now. Okay. The first thing, and it is very important for the addition method, is that both equations, they have to be in the form ax plus by equals c. So x's plus y's equals constant. Okay, so can you see that both of these equations that I have right now, they are in the form ax plus by equals c. Okay, this is going to be the easiest way to tackle the addition method, right? Both of them being in the ax plus by equals c form. Right? X's, y's equals c. X's, y's equals c. Okay, so the second thing that we're going to do is we're going to do an addition of these two equations or a subtraction of these two equations, whichever way you want to think about it. Okay, so remember that the rules of equations is the addition rule of equality and the multiplication rule of equality. They say that you can add or subtract whatever you want as long as you do it to both sides of an equation. You can also multiply or divide by whatever you want as long as you do it to both sides of the equation without changing the outcome of the equation. So we're going to take advantage of these rules to modify one of those two equations that I have on my system of equations. The goal, the ultimate goal, is to add those two equations, so add the left sides and the right sides of those two equations and make one of the variables disappear. So we want to transform one equation into a different form of the equation and try to make one of the variables disappear, right? So for example, looking at the x's, we have to find a way to make the x in the bottom, which is the easiest one, to become a negative 4x. If this guy over here becomes negative 4x, then adding these two terms, right, the 4x and the negative 4x, are going to cancel out, and this is going to make the x's disappear, right? The variable of the x disappear when I add them up. So I'm going to take the second equation that I have in here. Let's see if we can make a transformation to this, right? The second equation, this is equation 2. Now we have to look for a number so that when we multiply it to this 2x, it equals negative 4x. We want to convert it into a negative 4 because when we add a negative 4 over here on the top, those are going to cancel out, right? So the integer or the number that we have to multiply the 2x times is going to be negative 2. So if we multiply the 2x times negative 2, then that is going to make it negative 4x, and it can cancel out with the x in the top. Right now, if you multiply times negative 2, you have to multiply the whole left side of the equation, and also you have to multiply the whole right side of the equation. So you have to multiply both sides of the equation times negative 2, and this is not going to change the outcome of the equation. So let's see what's going to be left in here, right? So I'm going to distribute that negative 2. So this is going to become negative 4. Excuse me, that's supposed to be negative 4. Negative 4x. Then if you distribute to the next term, that's going to be negative 2 times 5y. This is going to be negative 10y equals, and on the right side you have to also multiply times negative 2. So 9 times negative 2, that should be negative 80. So this is nothing but my equation 2 transform, right? You multiply both sides of the equation 2 times the same thing. So it looks a little bit different, but it's the same thing as equation 2, right? Those two equations are equivalent. So now that I transformed the second equation so that it can cancel out with something in the equation at the top, let me just rewrite those again, right? So this is my first equation, 4x minus 7y equals negative 16. That's the first equation on the system. And now I'm going to take the second equation, transformed, right? You multiply times negative 2 both sides, so we can do the addition method. Now, when you have two variables, or two variables that have the same coefficient with opposite signs, they're going to cancel out. So we can do a virtual addition in here, right? I'm going to add those two vertically, and I keep that equal sign in there. So if you add 4 and negative 4x, those are going to cancel out. And that's the whole point of the addition method, to cancel out one of the variables. Then if you keep adding, you can add negative 7 plus negative 10y. That's going to be negative 17y. And then you can also add negative 16 plus negative 18. Make sure that you are adding those two, right? So that's an addition of two negatives. All you have to do is add up the magnitudes and give it the common sign. So adding those two negatives is going to be negative 34. And then at this point, you're left with a very, very simple equation to solve for. So we have to solve for y on this equation. So what do I do to solve for y? All I have is a multiplication of negative 17 times y. So what I have to do is I have to do the opposite operation of a multiplication, which is going to be a division. So you divide by negative 17, and if you do that to the left side of the equation, you have to do that to the right side of this new equation. Okay, and this is going to cancel out the negative 17s, and the result should be y equals 2. So that is my first component of, or on this system of equations. Now, the next step, the next thing that you have to do in here is back substitute. We're also, just like in the substitution method, we have to back substitute this number in any of the equations that I have. So let's go back and analyze which of those is going to be the simplest equation to substitute in. And just because I want to avoid negatives, right, I don't want to deal with negatives, I'm going to substitute in the equation in the bottom. Again, you can substitute in the equation in the top if you want. That has a negative 7y in there, has a negative 16. So I'm just going to try to avoid the negatives because personally I don't like to deal with negatives. So I'm going to write my second equation in here, which is 2x plus 5y equals 9. And I am going to replace all of the values of y for a number 2. Okay, so that's 2x plus 5, and then I'm going to substitute the number 2, comes from the y, equals 9, and all I have to do is solve for this simple equation. So 2x, I'm going to distribute the parentheses, that's going to be 5 times 2 is 10, equals 9. Then at this point I'm going to subtract 10 from both sides. I'm trying to send all the numbers to the same side. So this is going to cancel out the 10s. 2x equals 9 minus 10, that's negative 1. And the last thing that I have to do is get rid of that 2 that is multiplying with the opposite operation. So you divide by 2 the left side, you divide by 2 the right side. Those 2's cancel out. X equals negative 1/2. So this is my solution for the system of equations. Of course, you always have to include the domain first. In this case, negative 1/2 is the domain, that's the x value, and then the y value. So negative 1/2, comma 2. This is my solution for the system of equations. Again, remember where this comes from, right? If you have a Cartesian coordinate, you have the first equation, you have the second equation. This point will be represented by this coordinate over here.